Electricity powers nearly everything around us, but not all devices use electricity in the same form. The supply we get from the power grid is alternating current, or AC, which constantly changes direction. Most of our gadgets, from smartphones to laptops, need direct current, or DC, where the flow of electrons moves steadily in one direction. So, how do we turn one into the other? That's where the rectifier comes in. A rectifier is an electronic circuit designed to convert AC into DC. To understand how it works, let's start with the behavior of AC. Imagine a sine wave rising above and dipping below a zero line. The upper half represents current flowing in one direction, and the lower half represents current flowing in the opposite direction. Devices like microchips and batteries cannot handle this back-and-forth change, so we need a way to filter out one direction and keep only the forward flow. This is where diodes play a crucial role. A diode is like a one-way valve for electricity. It allows current to pass in one direction while blocking it in the other. The simplest type of rectifier is the half-wave rectifier, which uses just one diode. It clips away the negative half of the AC waveform, leaving only the positive pulses. While this gives us DC, it is very uneven, like a series of bumps rather than a smooth line. To improve this, we use the full-wave rectifier, which can be built in two ways, with a center-tapped transformer and two diodes, or with a bridge rectifier made of 4 diodes arranged in a square. In both cases, the idea is the same. Flip the negative half of the waveform upward so that both halves are positive. This results in a DC output that is more continuous, with less wasted energy. But even full-wave rectification does not produce perfectly smooth DC. Instead, the output looks like a series of humps, rising and falling with the frequency of the AC supply. To get closer to the flat, steady current our devices need, we use a filter, often in the form of a capacitor. The capacitor charges during the peaks and discharges during the valleys, filling in the gaps and smoothing the waveform. The result is a much more stable DC output. Of course, in real-life circuits, rectifiers are part of larger power supply units that also include regulators. These regulators keep the voltage steady even when the AC supply fluctuates or when the load changes. Without regulation, your phone charger, for example, could deliver unstable voltage and potentially damage your battery. Rectifiers aren't just for small gadgets. They're also vital in large-scale systems like power adapters, industrial machines, and even renewable energy setups. For instance, solar panels naturally produce DC, but when integrated with the power grid, inverters are used to switch between AC and DC as needed. The rectifier, in that sense, is one half of the story of how we manage electricity in modern life. So, to recap, AC alternates direction while DC flows steadily in one way. A rectifier, built using diodes, converts AC into DC by blocking or flipping parts of the waveform. Capacitors then smooth the output, and regulators keep it stable. Thanks to this chain of processes, the electricity in your wall socket can safely power everything from tiny LED lights to powerful computers.